7 space science and technology breakthroughs to watch for in 2026. Number 7. In-space computing and autonomy. Expect more autonomous rendezvous and proximity ops, satellites navigating to other satellites with minimal ground help. Earth observation birds will increasingly process images on orbit and beam down insights, not raw data. And at constellation scale, software will handle collision avoidance and fault detection in real time. The big idea: satellites become networked, self-directed computers in space, not just cameras on command. 6. In-space infrastructure, power, manufacturing, and logistics. 2026 is a year of demos. Think orbital tugs moving payloads between orbits, early in-space manufacturing with return capsules and tests for space-based power, beaming energy, sustaining lunar nights, and keeping hardware alive longer. If these get traction, space missions shift from one and done to serviced, upgraded, and supplied, more like a city than a campsite. 5. Planetary science and big observatories. Deep space science runs on patience. Watch for high-profile cruise phase flybys and instrument milestones, plus steady integration on the Nancy Grace Roman Space Telescope and Europe's Plato. The headline moments might be brief, but they unlock years of discovery, from exoplanet demographics to dark energy maps. 4. Earth observation and climate intelligence. Some of the most important space wins won't look spectacular, they'll look useful. Missions like NISAR aim to measure centimeter-scale changes to track quakes, subsidence, groundwater loss, and ice dynamics. Expect sharper satellite reporting on floods, fires, drought, and coastal change woven into news and disaster response. Space data is moving from cool picture to actionable signal. 3. Space domain awareness and the orbital environment. LEO is getting crowded, and that's everyone's problem. I'm watching early on-orbit results from missions like Sunrise for solar radio burst localization, plus multi-user platforms hosting sensors for tracking, comms, and maneuvering. Debris rules, end-of-life plans, and servicing demos matter here. Keep orbit safe and predictable, and the rest of this list stays possible. 2. Commercial human spaceflight and the post-ISS pivot. Low Earth orbit is changing hands. The planned VAST-1 crewed mission to Haven 1 targets 2026, aiming to host astronauts on a privately built station. If it flies and functions, it proves human stays in orbit can outlive the ISS on commercial hardware. That's a new business model, and a new chapter for how humans live and work in space. 1. Lunar surface science and exploration. The moon is back in a big way. Artemis II targeted a crewed lunar flyby in February 2026. The first humans beyond low Earth orbit since 1972. Add commercial landers like Astrobotic's Griffin Mission 1 and Firefly's Blue Ghost Mission 2 delivering NASA science, and you get a fuller lunar economy starting to emerge. Even without a landing, a human loop around the moon is the kind of instantly legible moment that can stop the world. Here's the pattern behind all of this. Public attention doesn't rise smoothly with budgets or launch cadence. It spikes when long, invisible R&D suddenly becomes visible. Think of the first full-stack Starship test, or the first James Webb images. Years of work collapse into a single memorable moment. So what's 2026 really about? 2 tracks running at once. Public milestones, a crewed lunar flyby, a shot at the first commercial station with people on board, dramatic deep space check-ins, future enablers, autonomy, logistics, power, surveillance of the space environment, and Earth data turning into decisions. Some of these will trend everywhere, others will quietly make everything else more reliable.